Start the recording again. Okay, so here, this is another of those techniques that is kind of amazing because you might have a substance that you don't know what it is, and you can figure out what the molar mass is, which is kind of amazing because to be able to know the molar mass, we need to know usually the formula and add up the weights. But this one, we don't know what it is. We can take something new, something that we don't know what it is, and determine its molar mass. How is that possible? We can measure the molar mass by actually using what is called the colligative property. So we can we can actually calculate the molality of the solution. So we can dissolve that substance into water and determine its freezing point or its boiling point. So let's say if we take the freezing point, we have to use this equation. And so we know the delta T. If we know the Kf for that, excuse me, we can measure the delta T. We don't know the molality, but if we know the Kf, we can do that. And for osmotic pressure, we can do the same thing. Once you know the molality, you can know the, actually this is not M, this should be N. This is the number of moles. So, no, this is the mass. No, you're right. Let me erase that. So this is correct. So this is M. So this is the mass divided by the molar mass will give you the number of moles, but divided by the kilograms of solvent will give you the molality. So we are substituting this by this expression. And then we're solving for molar mass. So the molar mass can be calculated from the Kf, the molality, the delta T that we observed, and the kilograms of solvent. We can do the same thing with osmotic pressure. We can calculate the molarity of a unknown compound by measuring its mass. This is the gas constant. This is the temperature in Kelvin. This is the osmotic pressure that we can measure. And we can measure again by applying the pressure to the one that has the highest concentration or the concentration of the solution we want to study, put in a pressure and observe that we have counteracted exactly the osmotic pressure. So we can calculate then what the osmotic pressure is. And this is the volume of the solution. And these two approaches are usually used for non-electrolytes, meaning for those substances that do not break into ions. Why? Because remember the Van Hoff factor. The Van Hoff factor can affect there's a theoretical and there's a experimental. So when there are non-electrolytes, then the number of moles is going to the I factor, the Van Hoff factor is going to be 1. So these are different solvents that they can use to be able to actually figure out what the freezing point depression is going to be. So let's go back here. This Kf is not the Kf of the unknown, but is the Kf of the solute, the solvent. And so we just need to know what is the solvent we're going to use. So we have the Kf for the solvent. We have the normal freezing point, and the normal boiling point and the KB. So we can use either of these four solvents, whether it's something polar or non-polar or medium polarity. And here you have another one that is non-polar. And so we can decide which solvent is going to be best for the unknown. We can test it where it dissolves and then measure its freezing point or its boiling point. And with that information, we can come back to this equation here and calculate the molar mass. The same thing can be done with the osmotic pressure. Okay, so let's look at a calculation of molar mass from freezing point depression. So this is the mass of the solute, which we should be able to convert the mass into grams. We can look up the formula of caffeine and then calculate its molar mass, convert the mass into moles. These are the grams of the camphor is the solvent. And this is the delta T is lower. So that means that this is the value of the delta T of freezing. Since the water is at 0, the lower, oh no, this is, excuse me, this is the lowering of the camphor freezing point. So it was 3.07 degrees lower than the pure camphor. And we have the Kf of the camphor. Let me just check that it wasn't one of the solvents. No, it wasn't one of these. So that's okay. But they gave us the Kf, so that's all we need. So they say calculate the molar mass of caffeine. So if we don't know if we cannot look up the caffeine, without looking up the caffeine, the formula, we should be able to calculate the molar mass from what they have given us. This is an experiment, and this is the data they have obtained. And so the mass of caffeine is in grams is 0.15 grams. The mass of camphor is 10 grams. The delta T is 3.07. The Kf is 39.7. So we have two masses, the delta T and the Kf. Let's go back to this equation. We have the Kf, this one, right? So let's put a check mark. We have the delta T. Let's put a check mark. The molality we don't have, but we have the mass of the, caffeine. We need to put it into here, into grams, because this will be molar masses in grams. And do we have the mass of the solvent, the camphor? I believe we do, and if we do, then we are all set. Yep, we have the mass of the camphor, 10 grams. We need to convert this to kilograms to be able to use it. We need to convert this into moles. In order to use it. Okay. So let's see. So here they're again showing you the derivation of the equation we're going to use to calculate the molar mass. So we have Kf, we have the mass, we have delta T, we need to calculate the kilograms of solvent. Oh no, we don't need to convert it to moles. Am I wrong? My bad. So this doesn't need to be converted to moles. So let me see. Let me just scratch it. Nope, we have the mass. So this one we need to do that. Okay, so the Kf value is here, 39.7. The grams of caffeine was given. It was given in milligrams. We need to transform it into grams. The delta T is here. It was given. And the grams of solvent was 10 grams, we needed to convert into kilograms, and that is the quantity in kilograms. Then we can operate these. These degrees centigrades are going to cancel out. The grams and the kilograms. This is grams of solute over kilograms of these units here. Let me just go like this. This unit is here. I'm encompassing in red here. Those are the units of molality. So this molality is going to cancel with this molality. And the molar mass is going to be in grams per mole. This is not molality. This is not molality. It has to be divided by grams per mole. So here is where the grams per mole will, divided by grams per mole, is going to remain here. And so is going to give you here the grams per mole. So this one is not completely cancelable with that. So this is molarity times grams per mole. Times grams per mole. So that will remain there. I never looked at these units that carefully. I just trust the formula. So just remember that the mass of the solute has to be in grams, the mass of the solvent has to be in kilograms. And that will give you the grams per mole. So 194. And I think it's 190, maybe it's 194, 196. Why isn't it exactly 196? If it's 186, it's because this is experimental value. The uncertainty is on the third decimal place, which means that this one is where the uncertainty lies. And so 196, if it's 196, is our answer is correct within the experimental values. Okay. Other colligative properties that can be used besides osmotic pressure and freezing and boiling point that we have already seen is going to be vapor pressure. Because when you have a pure solvent, this is the mole fraction. And the mole fraction is going to relate, is going to relate to the number of moles of the solute that you're going to put in. So when you have a pure solvent, the vapor pressure is going to be this one. When you add the solute that you don't know, you're going to decrease. So you're going to measure the pressure of the solution, and that will give you the mole fraction. Once you have the mole fraction, then you can calculate the molar mass. Okay. Great, so we have a few more minutes. Let me step out for a little while. I just want to open the doors for the people that are arriving so they don't have to wait in the hallway. So give me 30 seconds. Okay, great. So now we can do some visual problems. And with that, we'll call it a day. So asking us which process depicts the formation of a compound from its elements. And you have 9 of them. So there could be more than one, or there could be only be one. So take your time and let's figure it out. Okay, does anyone have one that they have recognized? That's a for me.
F, right?
I'm sorry, come again?
F?
F? No, you're very close, but no. The reason is this will be just the formation of the crystal. So you have in F, you have separate ions here, and they are coming together. So this is not, the ionic states are not the, sorry. The ionic states are, these wouldn't be the elements on their elemental states. Which process of information come from its elements? So these are not the elemental states for those. The elemental states are always neutral. And these are not.
Would D be one?
Yes, D will be. And I think that's the only one. Does anyone see anything else? So here we have two atoms. This could be, let's say, 2 atoms of sodium and a chlorine molecule, Cl2, that is breaking up to form sodium chloride. So in the process, there are electrons being transferred because they have to form ions. Like in here, this is an ionic compound, this is an ionic compound. So they have to form ions. But yeah, this will be in the elemental states. So this one is not the elemental states because these are already ions. And once you ionize something, it's not in its elemental state. Cool. Questions, comments? Okay, let's move to the next one. Which process depicts a transfer of electrons? And I can see more than one already. So what do you think?
Would E be one?
Which letter?
E?
B.
No, E.
D as in boy? D as in boy?
Like E?
Like a bus?
See, I
Like
think
E,
an elephant.
Yeah, E as an elephant.
Okay. Anyone else has spotted another one? There are 3 actually.
Do the ion ones count for like F and G?
F and G. No, they are not. Those ions are just coming together and forming a crystal, right? They're attracted, but they're positive and negative ions, and they remain positive and negative ions. So there is no transfer of electrons in F nor in G.
what about B?
B as in boy.
Yeah.
B looks like it's a diatomic molecule and it's separating, but I don't see any charges, which means that no, there is no transfer of electrons there either. How about A? What do you think is happening to that atom in A?
Is it just arbitrarily losing an electron?
Yeah, it's losing an electron. So there's a transfer of electrons. So it's transferring the electron outside. So it's becoming smaller. Usually when an atom loses electrons, it becomes smaller. So to be able to become positive, it has to have transferred an electron to something else. So that depicts a transfer of an electron. Okay, so A is one. There's two more. Anyone?
H.
H, correct. H is gaining an electron. Is going, let's say this would be a chlorine atom going into a chloride atom. So, or a chloride ion. So, yep, and which is the third one?
Is C the third one?
C, no, these are just molecules of water kind of doing a dipole, ion dipole interaction, correct? So there's no electrons being transferred in there. The third one is less obvious. It's D as in David. I'm not sure if the first person that actually answered was saying D. I was listening to B. What I heard was B, but D as in David. What are the, is there a transfer of electrons for D? And what's your guess? What's happening? What's the product of that reaction? What kind of compound or substance is being formed? Does it look like a molecule to you? Or is it something else?
I mean, it's a compound, right?
It's a compound, correct? What kind of compound? Do you see covalent bonds or do you see ionic bonds?
For D, right? You're saying
Or D as in David? Mm-hmm.
covalent.
Covalent? In covalent, they'll have to be interpenetrating. So like, can you see my pen? No, I'm going to. So covalent means that you'll see the two atoms kind of interpenetrating each other, overlapping. So this will be covalent. I don't see this covalent. Actually, if you notice here that these atoms seem to have gotten a little bigger. This arrangement here is an ordered arrangement. So this is usually a solid. And it consists of ions. So there's going to be positive ions, which usually are the smallest of the two, and negative ions, which are usually the largest of the two. So what is happening here is these neutral atoms are becoming positive ions here, and these green atoms are becoming negatively charged. So to be able to become negatively charged and positively charged, they have to undergo what is depicted in A, and A as in atom, and H as in Harry. So they have to lose and gain electrons, and that is what is happening here. Does that make sense? So this D, A, and H reflect a transfer of electrons. So these are positive. They didn't show the positive and the negative, although maybe they should have been more specific. But yes, these, I would like you to look at these as an ionic compound. So this and these are ionic compounds. So in F, as in friend, the ions are just coming together. So there's no electron transfer there. They're just electrostatic attractions. They have already transferred electrons early on, not in the process that is reflected by the arrow here. Okay, let's keep moving. Ion-dipole interactions. Do you see any ion-dipole interactions?
Probably C.
I'm sorry, come again?
C is in cat.
C on the top. Yes, those are ions. You have positive ions and negative ions, and you have dipoles, which are the waters. So E, if you thought about E, there is dipoles, but there's no ions. There's just molecules of water. So that's there's no ion dipole. There'll be dipole, but not ion dipole. For ion dipole, there have to be ions. Cool. So there's only one, and that is C as in Charles. Which process required the input of energy to overcome intermolecular forces? So which ones are, in which of these processes intermolecular forces are overcome?
B, E, and G, because bonds are being broken.
So let's look at B. Let's start with the first one. B, what kind of bond is here? Is keeping those two together?
Covalent.
Come again?
Covalent.
Covalent bonding, correct. Yeah, they're overlapping one another and interpenetrating one another. So that means that you are breaking a bond. And a bond is not an intermolecular, it's an intramolecular. To have intermolecular, you'll have to have more than one molecule, correct? And there's only one molecule here. And what you're breaking is an intramolecular force, which is called covalent bonding. So that would not be there. So you mentioned B probably. That's the first one. It isn't B. You mentioned 3. Which is the second one you mentioned?
E.
E?
Hydrogen bonds being broken. That'd be intermethylate, right?
Yeah, so this one is not, so let me put an X, just to make sure that everybody understands. Here we're breaking these dotted lines, correct? We're separating the molecules of water. They don't show here on this end, they don't show hydrogen bonding. So we are breaking hydrogen bonding. Is that an intermolecular force? Hydrogen bonding? And the answer is yes, it is an intermolecular force. So yes, E is correct. And you mentioned a third one. Which I don't recall. Can you tell me what the third one was?
G.
G. Okay. So let's look at G. What kind of substance is this, we said? Covalent or ionic?
Ionic.
Ionic. And so to be able to break the particles apart, you are overcoming electrostatic forces. Will those be intermolecular? I would say, as I teach it, the book says that actually it took away ion-ion as an intermolecular force and put it into the next chapter, in chapter 11, in this chapter that we're working now. So 11.1 talks about ion-ion. To me, I would say yes, I will consider them intermolecular forces. So yes, because they're either molecules of ions. This could be an ionic compound like ammonium, which is a molecular ion, and sulfate, that's another molecular ion. And there is attractions between them, and there is attraction between, so they're intermolecular, and the attraction is electrostatic. So when we're talking about intermolecular, we usually say these are either molecules or ions. So in this case, I would say, yeah, yep, I agree with you. So I'm going to say yes, because I think I agree with you, and that's how I view it. The book, I'm going to put a question mark, because the book actually kind of doesn't include ion-ion as intermolecular. But that's just a matter of convention. So it depends on which convention you follow. So this will be kind of a little bit indefinite because it depends on the convention you're following. To me, yes, I would say yes. Okay? Any more questions on this one? Okay. And now we're going to go into multiple choice questions. So what I would like to do before you leave is going to be, please send me an email right now within the next 5 minutes through Canvas and let me know that you were in class. We did some class activity, we solved problems, and that will be considered, instead of the Kahoot today, we're going to use, I'm going to use your email as the reason to give you credit for today's class activity. Okay, great. So I think I want to stop. Unless there are any more questions, or anyone else could have comments or questions, then we can address them. Otherwise, we can call it a day.
I had a question about the exam.
Yes.
So for the second attempt, do we have to, like, is there a certain amount of time in between the first and the second attempt that you have to start it, or?
No, there is no. It expires at 11:59. So you need to, if you're in the, let's say you wait till 11:40 or 11:11 to start. No, it's 60 minutes. So you're not going to get the 60 minutes. You're going to get only 59 minutes, whether it's your first attempt or your second attempt.
Okay, that makes sense. Thank you.
Yes, you're welcome.
Since it's on Canvas, did you make all the questions?
Yes, I've written all the questions. So if you think they're wrong, please send them to me. This is the first time all of those are brand new questions. And
are they pretty similar in format to the Alex, or are they a little different?
They're similar. I would say they're similar. There's still my pictures, and so I took some from Alex. If you see a question for chapter 11, try to answer it. I'll probably give you credit anyways for it, even if you don't have it, since I made a mistake, put some questions. I think I have, no, maybe not. Osmotic pressure? Not osmotic pressure. I have, no, I think it's still Raoult's law. Yeah, I think Raoult's law is fine. I'm confusing it with the partial pressure. So I think it's fine. But if you have questions about the question, please do not get frustrated. Just say, okay, well, I need to talk to Dr. Vides. I know this. Okay. So.
And then we get extra credit for having the previous homework done on time or something, right? Or was that a thing? Or is that for the final?
Which homework are you talking about? Which homework are you talking about?
Like the homework 10, right? Because for each exam, or is that for like the final? If we have the Alex.
Yeah, that
typing complete.
So you have until the day of the final to finish those for the second part of the credit for the homework. Okay, so don't forget to send me the email if you want to get credit for today's activity.
Should we send you an email or should we send it on Canvas?
On Canvas. I'm sorry, I refer to the emails as Canvas. Yeah, only through Canvas. Only message me through Canvas. So there's really an email system because you can attach things. You cannot get very fancy with the formatting, but I consider that the email. When I say email, it's always through Canvas. Thanks for your question, because otherwise I would have to fish them out of hundreds of them that I have in my Gmail. Any more questions?
I have a question about the exam.
Yeah.
How many questions did you say it was?
Ooh, I don't remember. There are about 20, maybe 20, lower 20s. I don't recall. I'm, I, when I finished the test, I looked at them and then I said, I haven't looked at the questions. So I looked at the questions and I tried to remember, but I don't remember. It's 20 something.
It
Okay.
says that it
It's
says
60
15
minutes.
questions.
I'm sorry?
It says it's 15 questions.
15 questions. Yeah. Okay, good. So
And
it's
then-
this. So some of them I'm going to grade them manually. So they are called essay questions. So you're going to enter some of your results you're going to type them in, and they're not going to be graded until I grade them once the test is over. I think there might be a couple of those. But there are some numerical problems that you will get feedback immediately when you look at the results, whether you have gotten it right or wrong. But there's a couple of them that are going to be graded by hand. So don't panic. I'm going to be pretty lenient, and just if something happens, just let me know. I'm here to help you, and so as long as I don't feel that students abusing my goodwill, I will keep the goodwill for you to do that. So please do not panic if something happens during the test, or you say, I have no idea what is he thinking about, or maybe something is wrong and you cannot solve the problem. Then I've tried my best. I'm not infallible, so just be patient. Okay, great. So I need to wrap this up. Unless I'll take one more question. If there's one more question. Okay, so I'll wait for your email, and I will see you on Monday. Remember that there's going to be a homework due tomorrow for chapter 11. Okay, see you soon. Bye.